Okay, Unit 5, Day 6, Solving Quadratic Word Problems. The path of a paper airplane is represented by h equals negative t squared plus 14t minus 45, where t is the time in seconds and h is the height in feet. So along the x-axis here, we have our seconds. And along the y-axis, we have our height in meters of the paper airplane. So now we're being asked to factor this equation. So let's write it out again. The problem with it in its present form is that we've got this negative number in front of the t squared. Our a value is negative. So what we're going to do to make this a little bit easier for us is we're going to use a common denominator of -1 to factor out that negative. So when we do that, we end up with an equation t squared minus 14t plus 45. And this is much easier for us to factor. So we're looking for a pair of numbers which add up to -14 and multiply together to be 45. And those two numbers just happen to be -9 and -5. Hopefully by now you're getting a little better at being able to factor these, perhaps without having to write out all the factorials. Perhaps you can do it in your head. At any rate, our equation in factored form is now t minus 9, t minus 5. And this means that our x-intercepts will be 5 and 9. So we'll just put them in here. Now we're looking for the midpoint, or the axis of symmetry, between these two x-intercepts. And we can get that by adding them together and dividing by 2. And this will give us an axis of symmetry of 7, as represented by this green line here. Now we can take that value of 7 and plug it back into the original equation to find out what the y value is going to be for our vertex. We know the vertex will fall somewhere on the axis of symmetry. We know that it's going to have an x value of 7. So we plug that back in to find out what the y value is. And when we do that, we end up with a value of 4 for y. So we know that our vertex is 7, 4. We can sketch in our parabola there. And that'll represent the path of the paper airplane over a period of a few seconds. 9 to be exact. All right, a car driver brakes and skids through an intersection. The investigating police officer knows that the distance a car skids depends on the speed of the car just before the brakes are applied. She uses a chart to determine the car's speed before the skid. Draw the graph. All right, a little traffic accident forensics here. So, in this table, given a certain speed, we're told how long the skid would be. So at a speed of 50 kilometers an hour, it would leave a skid of 18.5 meters. So we can plot all these points on our graph, on our Cartesian plane, and we can use these various points to give us a little insight as to what's going to happen given a certain speed or a certain length of skid. So the first question we're asked is, use the curve to estimate the initial speed of the car if the skid is 41 meters long. So here is the length of the skid. So what we do is we go up until we find 41 meters on the y-axis, and we draw a line across here at the 41 meter mark until it reaches the parabola. At this point, we head down, we draw a straight line down here until it reaches the x-axis, and we can see that at 41 meters of a skid mark, the speed must have been approximately 75 kilometers per hour. So there's our first answer. Our second question is, use the curve to estimate the length of the skid mark if the speed of the car is 95 kilometers an hour. So this time we're given the speed first. So we come along our x-axis here until we reach about 95 kilometers an hour. We draw a line straight up from there until it reaches the curve of the parabola, and then we draw a straight line from there until it reaches the y-axis, and it reaches at this point right here, which tells us that at a speed of about 95 kilometers an hour, the length of the skid will be 70. This little chart here is just an extension of the previous chart. We were told a bunch of values, and I believe it went up to about 90 kilometers an hour, indicating that the length of the skid would be about 60.3. But you may have noticed a pattern of first differences and second differences, and we can use this pattern to try and predict what it might have been at a speed of 100 kilometers per hour, what the length of the skid would be. It's not actually asked as part of the question, but just if your interest takes you this way, you can explore this a little bit more. All right, reviewing a rock. We did this earlier in the unit. We had a cliff of 210 meters in height, and we had a rock that was falling off this. And as the rock fell, the acceleration of the fall became greater and greater and greater. So here we have the same rock, the same equation, and we're being asked a few questions about this. So, by filling in the table of values, we get these various coordinates at the point of 0 seconds, 1 second, 2 seconds, and we're told just what the height of the rock is going to be at various intervals. Now, our question here is, what is the height of the cliff? So the height of the cliff is going to be equal to the height of the rock at 0 seconds. So at 0 seconds, the rock, before it's been dropped, is at a height of 210 meters. So we can presume that the rock is being dropped at the same height as the height of the cliff. So there's our answer to the first question. 210 meters, height of the cliff. Next question is, how long will it take the rock to reach the bottom of the cliff? And they provided a little hint. At what time does y equal 0? Well, y is the y-axis does indicate what the height is. So at a height of 0, we can see that the time is approximately 6.5 seconds. Right where the x-intercept is. And our last question is, how far from the bottom of the cliff is the rock when half of the time has passed? Well, we've established that the time is 6.5 seconds, so half of 6.5 is 3.25 seconds. So now all we need to do is travel along the x-axis, 3.25 seconds, draw a straight line up from there until we hit the graph, and then turn and head over to the y-axis, which shows us that there's a height of approximately 155 meters at the 3.25 second mark, thereby answering our last question.